Welcome back to the Deep Dive, where we take your sources, extract the absolute must-know insights,
And give you that competitive edge.
whether that's in conversation or, as is the case today, out on the course. Today, we are focusing all our attention on what I think is maybe the most high-stakes, stomach-churning shot in golf.
The short putt.
The short putt. We're talking specifically about those putts inside 10 feet.
The ones you feel you absolutely have to make.
You know you should make them. So we dove into sources that explore this really deep relationship between confidence and competence on the green.
Specifically, research that looks at how data tools, like one called Puttalyze, can help.
Right. And our mission today is to figure out why these seemingly simple shots become so intensely challenging, both physically and, I think this is the core of it, mentally.
Especially when the pressure is on.
And here's the core finding right out of the gate. It really hits hard. Many golfers, and if you play golf, I guarantee this applies to you, suffer from a significant, debilitating gap between their confidence in making these short putts.
And their actual measured competence.
Exactly.
Yeah.
Walk up to that 6-footer, assuming, a 95% success rate.
But the reality, even for really good players, is dramatically lower.
And that gap,
Yeah.
that disconnect,
Yeah.
that's what destroys performance, isn't it?
It's everything. Think about it. For a 6-foot putt, the amateur's expectation is 100%.
Yeah, you feel like a failure if you miss.
Right. But even the best tour professionals in the world only make them around 75% of the time.
So we're holding ourselves to a standard that is literally impossible.
Exactly. And when you do that and you don't have a reliable, objective process to fall back on, that pressure just becomes crippling.
That's the psychological wall.
That's the wall we're trying to tear down.
Okay, let's unpack this.
Let's do it.
Because this deep dive is all about using real, objective data to tackle this problem. We're moving beyond intuition, beyond guesswork.
All that old advice about feel.
Yeah, and we're trying to inject some hard physics and science into the equation.
To do that effectively, we have to first really elevate our understanding of what a putt actually is.
It's not just hitting a ball at a hole.
Not at all. We simplify it in our minds, but every single putt is a complex, completely unique interaction of forces.
Okay, so what forces are we talking about?
Well, there are 3 main variables that define every putt you face, and they're constantly interacting with each other.
3 variables. Got it.
First, you have the slope of the green. That dictates how much the ball is going to break.
The curve.
The turf. Then you have the speed or the pace you put on the ball.
How hard you hit it.
Exactly. That affects how much the ball can resist gravity. And of course, you have gravity itself always pulling the ball down the fall line.
So relying purely on intuition, especially under pressure, that's basically doomed to fail. Because those 3 variables are never the same twice.
Precisely. If you are standing over a 3-degree slope, hole is 8 feet away. That exact moment in physics has never happened before.
And it'll never happen again in the exact same way.
Never. Guesswork fails because you need to solve an algebraic equation slope plus speed plus gravity for every single shot.
And unless you practice with tools that can simulate and measure those realistic green conditions,
You are never truly training the right skills for the course. You're just hoping.
and this brings us immediately to the most common and maybe the most ineffective practice method that we all use.
The flat, indoor putting mat.
We all have one.
We do. And let's be fair, they aren't useless.
Right. Okay, let's acknowledge the benefits. They are fantastic for the purely mechanical aspects of your stroke, right?
Absolutely. For things like rhythm, tempo, making sure the putter face is square at impact.
Keeping a consistent path.
Yeah, it's great for perfecting the machinery of the stroke. No
Yeah,
question.
And this is a big but.
Here's the critical failure, and this is where the sources draw a really bright line. Flat surfaces fundamentally lack the environmental complexities of a real green.
So all those variables you just mentioned.
Gone. When you're on that perfect rug, you're missing slope, you're missing undulation, and crucially, you're missing the variable pace that comes from different grass or moisture.
The very things that define putting on a course.
Exactly. And the consequence of this type of practice is what the research calls a gradual decline in perceptual calibration.
Okay, that sounds important. What does that mean, perceptual calibration?
It's key. It means that without those relevant environmental cues, the slope, the break, Your brain simply cannot develop real-world green reading skills.
So my internal computer is getting bad information. It's learning the wrong thing.
It's being trained for a world that doesn't exist.
I've felt that. You practice indoors, you feel great. Then you step on a real green and you see a tiny 1-degree tilt.
And you feel completely lost.
Totally lost.
Because the reality of the course is that no two putts are ever alike, and the slopes are the primary culprit.
They don't just curve the ball.
No, they completely reshape the trajectory. They dramatically influence the capture speed you need for the hole, and they profoundly distort your visual perception.
Your eyes are literally lying to you.
Your eyes are lying to you. What looks straight isn't. What looks fast is slow.
Okay, let's nail down some jargon here, because you mentioned the fall line. Can you just clarify for the listener what that is?
Sure. The fall line is simply the steepest downhill path from your ball to the cup.
Okay.
Think of it this way. If you poured water on the green, the path that water takes is the fall line. It's the straightest line of descent.
And every putt breaks relative to that line.
Every single one. If you misread the fall line or how steep the slope is relative to it, you've already lost the putt. Your mechanics don't matter at that point.
And that is the root of the whole psychological problem we started with. You struggle with pace. You struggle with reading the green.
Because you haven't trained for it.
And that failure leads directly to that paralyzing moment of hesitation and self-doubt right before you swing.
That's the confidence killer. That's the gap.
So if intuition is failing us and flat mats are training us for a game that doesn't exist, we have to move from assumption to data.
We need to bring clarity to the complexity.
We need a system that calculates the variables. Here's where it gets really interesting.
Yes. The solution proposed in the source material, and it's exemplified by systems like Puttalyze, is a methodology built on objective calculation.
It moves past feeling.
And into hard data. It helps the golfer understand not just where they should be aiming, but precisely why that aim point is mathematically correct.
Based on the physics of that specific moment.
Exactly. You're transforming the ambiguity of the green into a solvable problem. But to do that, you need highly objective measurements.
Right. Now, this sounds like a lot of work before, a casual round.
The idea is that this is for training so that it eventually becomes reliable intuition.
Okay, so what are the measurements? The system details 5 key parameters, 5 inputs the golfer has to gather.
Right. 5 pieces of data.
The first one is green speed. You need a baseline for how fast the surface is. This is usually measured with something called a Stimpmeter.
Let's pause on that because it's essential. A Stimpmeter is a really simple tool. It's just a little ramp.
Okay.
You release a ball from a consistent angle and you measure how far it rolls. That gives the green a number like an 8 or a 12.
And that number tells the calculation how much friction there is.
Precisely. It's the core pace variable.
Got it. So input 1 is the friction factor. What's input 2?
The second is the slope percentage.
The actual severity of the incline, not just guessing with your eyes.
Never guess. That's the gravity factor. Slope has a highly nonlinear effect. A 1% slope is manageable, but a 3% slope demands exponential adjustments to your aim.
So you need a digital level or some other tool for that.
You need an objective measurement. It's paramount.
Okay. Input 3 is the obvious one, the distance to the hole.
Simple, but vital for modeling the trajectory.
Input 4 is the angle relative to the fall line. You explained the fall line earlier. Why is our exact angle to it so important?
Because that angle determines how much the ball is fighting gravity versus succumbing to it. If you're putting straight up the fall line, gravity just slows you down. If you're putting 90 degrees across it, gravity is pulling you sideways for the maximum break.
And most putts are somewhere in between.
Exactly. Knowing that precise angle tells the system exactly how much curvature is required.
Okay. And finally, the 5th input, which sounds incredibly technical. The desired ball speed, measured in rotations per second, or RPS.
Yeah.
How is the average golfer supposed to figure that out?
That's a great question because this is where the data shifts from the environment to your execution.
From the green to me.
Yes. The sources suggest that to truly calibrate, you need training tools that can accurately measure the speed you impart on the ball.
So it's the difference between guessing how hard you hit it and knowing how fast the ball is traveling off the putter face.
And without that precise knowledge, even with a perfect aim, you'll still miss. It's the other half of the equation.
Okay, so once the golfer has fed these 5 very precise parameters, speed, slope, distance, angle, and pace into the system, what happens? What does it calculate for you?
Once those 5 data points are processed, the application models the exact physical trajectory, and it spits out 3 objective visual data points for the golfer.
3 outputs.
3 outputs. And these are the key to building confidence because they eliminate all the guesswork.
Okay, what's the first one?
First, it provides the ideal aim point. This is the exact spot on the ground, a blade of grass, an inch marker where you need to start the ball.
The spot that perfectly accounts for the break.
For the break caused by the slope and your chosen speed. So that aim point is what replaces your traditional unreliable read.
Right. What's the second output?
The second is the ideal distance point. This is absolutely critical for pace control.
Okay.
It tells you, based on the slope and the speed of the green, how far past the hole the ball needs to roll if it misses.
So on an uphill putt, it might be 2 feet past the cup.
But on a downhill one, it might only be 6 inches past. It's the target pace, quantified.
So it's not just about line anymore, it's line and speed, both quantified.
That's right. And the third output is the projected ball trajectory, a visual line on the screen.
And what's the point of that?
This allows the player to compare their intuitive read, where they thought the ball would go to, the physical reality of the calculated path.
Ah, so that's the feedback loop.
That is the moment of perceptual recalibration. That's how you retrain your brain.
So let's discuss the real impact of this on you, the person trying to get better. This system transforms putting from, a vague, hope-based ritual into a precise, calculated process.
It guides both your decision-making and your perception.
And when you know exactly what the physics require, you have an aim point backed by numbers and a pace backed by a distance point. You have the 2 key elements that overcome that fear of failure.
You're not guessing anymore. You're executing a plan.
And that's the long-term benefit.
Yeah.
It's not just about making one putt in practice.
No, it's about integrating these 2 skills. Through repeated use of this method, the player develops both a refined intuition.
Because they start to internalize what the data looks like on different slopes.
Exactly. And they also develop extreme precision because the data holds them accountable every single time.
So intuition and precision working together.
That combination builds a reliable, adaptable stroke that is actually suited for real-world course conditions.
And it directly tackles that hesitation and self-doubt we identified at the very beginning.
Because you've replaced the paralyzing feeling of, I hope I read this right, with the certainty of, I calculated this correctly.
So what does this all mean? At the end of the day, it means we move from being overwhelmed by the complexity of slope and gravity.
Seeing them as these, insurmountable obstacles.
They're actually using those factors as measurable inputs.
Yeah.
We're replacing the unreliable eye and the faulty calibration from flat mats with objective data.
It's a complete reversal of the typical approach.
How so?
Instead of just beating balls on a flat surface and hoping our mechanics stick, we are training our perception and decision-making on realistic surfaces first.
And then we let our mechanics follow the direction of the data.
That is how you truly bridge the competence gap.
Okay, we have completed the deep dive into short putts. And we learned that the common failure inside 10 feet is often a crisis of perception.
Exacerbated by poor practice habits that just don't account for reality.
That feeling of fear and doubt on the green is the psychological symptom of what you called inadequate perceptual calibration.
Exactly. And the key to unlocking true, sustained confidence is replacing that unreliable intuition with hard data.
Data about slope, speed, and projected trajectory.
It's about training your brain to see the green not just as a landscape, but as a system of solvable, measurable variables.
Now for the final provocative thought for you to mull over. Our sources repeatedly emphasize that slopes distort visual perception. Just looking at a slight incline can trick your eye and your brain into completely misjudging everything.
The numbers prove our eyes lie to us.
So if something as subtle as a 1-degree slope on a golf green can skew our objective reality and cause us to fail repeatedly.
What other complex daily tasks or professional problems are we approaching with visually distorted or poorly calibrated assumptions?
When a simple set of objective measurements, Stimpmeter for a life, if you will, could bring true clarity.
That's a great question. How often are we just guessing?
Something to think about the next time you encounter an assumed flat surface or an assumed simple problem. Thank you for diving deep with us.
Thanks for having me.
We'll see you next time.